Synthetic division is the next thing that's kind of up to bat for us. And this is going to lead us into the rational root theorem, and the rational root theorem is going to lead us into being able to find all 5, 6 zeros of a fifth or sixth degree polynomial. So we're going to really be using this skill a lot as a guess and check kind of method. You know, let's look at a fifth degree polynomial. Let's see if 1/2 is a 0. Let's see if 1 is a 0. Let's see if 2 is a 0. Because if we can find a 0, then we can use division, find the remainder, find a 0 of that polynomial, take the remainder of that, find the 0 of that polynomial, and so on and so forth until we get it to a quadratic where we can use one of our quadratic techniques to solve. Okay, so synthetic division is a very important tool in finding zeros of higher degree polynomials, as is long division. And when we look at synthetic division in just a second, you're going to ask, why in the world would we ever use long division if we have synthetic division available to us? Because it's way quicker. Long division is long. Synthetic division is very quick, but we'll see some limitations as we move through. Long division is critical. We have to have it for certain situations. All right, so here's what the synthetic division problem looks like. As I mentioned, synthetic division is going to be used to find roots, rational roots specifically. Tomorrow we're going to look at the rational root theorem. But the number that can be substituted for the variable to make the polynomial 0 is what a root is. And so the root of, this is the important part of this little slide here, the root of x plus 3 is -3. Right? I know that color is a little bit difficult to see. Any of you are red-green colorblind, you probably can't even see the numbers there. So x plus 3 is -3. That's the root. The root of 4x minus 3 is 3/4 is what that says. Okay, the root of x plus 3 is -3. The root of 4x minus 3 is x equals 3/4. It's the 0. What does it equal or equal 0? So our divisor in synthetic division, we're always going to use the root of the divisor. So it's important if we have a divisor like x plus 3, the value that we're going to use is going to be -3. If we had a divisor like 4x minus 3, we could use 3/4 as our divisor, but 4x minus 3 might push us into long division because the 3/4 is going to make things a little bit tricky. Okay, so let's look at our first example. We have x squared plus 3x minus 8. And again, this fancy notation times x minus 4 to the -1. Remember, that's the same as saying that this is over x minus 4 or is being divided by x minus 4. So anytime you see that notation, and I use that notation here because your textbook uses it, I want you to understand that they're telling you that that's division. So this is x squared plus 3x minus 8 divided by x minus 4. So we're going to start by finding the root of the divisor. What is the root of the divisor? What's the root of x minus 4? Positive 4, right? Because x minus 4 equals 0 when x equals 4. So that 4 is going to play into it. So here's what the synthetic division process looks like. Just watch it, and then we'll kind of give you a chance to rewrite it. All right, so you're going to draw a little box like that. The root goes in that box. So 4 goes in that box. Beside that box, we're going to put the coefficients of the dividend. So the coefficients of x squared plus 3x minus 8, what are those coefficients? 1, 3, and -8. That's what goes there. All right. Next step in the process is you skip a line and draw a line. I'm going to give you a chance to write all this if y'all want to just watch. Skip a line and draw a line. All right. And then we're going to drop down whatever the first coefficient is. In this case, it is 1. We're going to drop 1 all the way down. And then in the long division process, what did we do? We divide, we multiply, and we subtract. in the synthetic division process, you're going to bring down that first term and you're going to multiply, and instead of subtract, we're going to add. All right, so 4 times 1 is 4. We're going to multiply in that pattern, so 4 multiplied by 1 is 4. And then you add 3 plus 4, which is, what's 3 plus 4? 7. And then we multiply again and add. 4 times 7 is 28. And negative 8 plus 28 is 20. This value is the remainder. Okay? So the solution is always going to start with, because I'm dividing a second degree polynomial by a first degree polynomial, it's always going to, the answer, the quotient is always going to be 1 degree less than your dividend. So since our dividend here is a second degree polynomial, our answer is going to be a first degree polynomial. 1x to the first plus 7 plus 20 over x minus 4. So that last thing is our remainder. All right? And we're going to look at this whole process again, and then I'm going to make an observation. Okay, so let's just kind of back up several steps on this PowerPoint slides, and let's just talk through the process again. Start by drawing us a little box. Put the root of the divisor in the box. So x minus 4 has a root of positive 4 because x minus 4 equals 0 when x is 4. Okay, put the coefficients of the dividend. This is the dividend, the part that I'm dividing. Right? The coefficients are 1, 3, and negative 8. Skip a line, draw a line, and bring down the first term. Then we multiply and add. 4 times 1 is 4. 3 plus 4 is 7. 4 times 7 is 28. Negative 8 plus 28 is 20. So that means that our solution is x squared, x to the first plus 7 plus 20 over x minus 4. All right? Y'all okay with that? And the process will get a little bit clearer as we move forward. It won't take nearly as long because we're not going to spend time explaining every step. Now, before we move on, I have to make this observation. All right. If we were looking at x squared plus 3x minus 8 as a function, f of x equals x squared plus 3x minus 8. F of 4 would be what the function value is if we plug 4 in for x, right? And I can tell you, because of this synthetic division process, that f of 4 is 20. If you plug 4 into that, 4 squared plus 3 times 4 minus 8, you get 20, but it's always going to be the remainder of what you would use for synthetic division. Now, that's not a time saver in this case because you can plug 4 in pretty quickly, but what if this was a 5th degree polynomial? You don't have a calculator and you have to evaluate that polynomial at -3. The synthetic division process is a very, very quick way to evaluate the polynomial. All right, this is called the remainder theorem. Okay, the remainder theorem tells us that if we do this process, the remainder here is the function evaluated at that root. Okay, so we generated a point by doing this process. Whenever x is 4, y is 20. All right, now the significance of this, guys, the significance of what I just showed you is if we are really, really lucky and we do this, we come out and our remainder is 0, what does that tell us about this number? What is this called? It's an x-intercept, which is also called a root, which is also called a solution. It's also called a zero of the polynomial. Okay, so that's an important deal. If in the synthetic division process, if we plug this number in and we get 0 out, that tells us that this number is a zero. Excuse me, that's the wrong thing too. It's a zero of that polynomial. All right, if you got a 0. This isn't. Right, this polynomial doesn't. This thing gives us 20. But anyway, we'll see that as we go. That's a little bit of preview of what we're going to use this for tomorrow with the rational root theorem. All right, next example. X cubed minus 5x squared plus 7x minus 12 divided by x plus 2. Okay, what's the starting off point for the synthetic division process? Find the root of the divisor, right? What's the root of x plus 2? -2. So I'm going to draw this. I'm going to draw this little box here, and I'm going to put -2 inside. Now beside it, what am I going to put? Coefficients of the dividend. So that's 1, -5, 7, -12. And again, you have to be really careful that you do not leave out any powers. If there's a missing power, just like in long division, you have to put it there. The problem with synthetic division is you're not going to get a mismatch of like terms like we did with long division because there's no variables here. So if you leave it out, you get the wrong answer. And that's a big deal. You might notice it at the end, but it's not really likely that you will. So what are we going to do here? Multiply and add. 2 times -1 is -2. Add those together. Same sign, add and keep. That's -7. 2 times -7 is +14. Add those together, we get 21. -2 times 21 is -42. Add those together, and we get our remainder of -54. So our solution, these are the coefficients. Will, these are the coefficients of my solution. What power does my solution start with? X squared. Why is it x squared? Because I'm dividing a cubic polynomial or a third degree by a first degree, so that my answer is going to be a second degree polynomial. All right, it's actually a rational equation because it has a remainder, but this would be 1x squared minus 7x plus 21 plus my remainder, which is -54 over what? X plus 2. Now, if you look back at our process from yesterday, we're going a little slow with this. You could really fly through some problems like this. You got to be careful, of course, but it's a lot quicker than the long division process is.
How'd you get 7x?
The powers are always going to decrease, right? So if I start with x squared, my next term has to be x to the first, and then my next term is going to be the constant. All right, so these are the coefficients. So it's going to be 1x squared minus 7x plus 21, x is 0, which is just a constant expression. And then the remainder is there. Now, you could write plus -54 over x minus 2, or you could write that as minus. But be careful with that. Either way is correct. Okay, so the -2 goes inside, the coefficients drop down, skip a line, draw a line, bring down the 1, multiply and add, and we get x squared minus 7x plus 21 plus -54 over x plus 2. All right, next example. What do you notice on this problem? The x cubed is missing, right? So when you write this problem down, as you write this problem down, write it with the x cubed, 0x cubed. If you forget that in the synthetic division process, there's nothing that's going to tell you that you forgot it. All right? So we're going to start with our little box. The root of the divisor is what? What's the root of x plus 1? Negative 1 is the root of that divisor, so that goes in the little box. And then we're going to bring down our coefficients. 1x to the 4th, 0x cubed, negative 8x squared, positive 1x, negative 10 is my constant. Skip a line, draw a line, and bring down the whatever the first term is. It could be a 5, it could be a 7. Whatever that first term is what you drop down. So you're going to bring down a 1. We're going to multiply and add. Negative 1 times 1 is negative 1, right? Combine those and we get negative 1, right? Am I going too fast? Anybody behind me? All right. Negative 1 times negative 1 is positive 1. So you can see right now where you could really, there's a lot of negative multiplications, additions, subtraction, integer operations. You got to be really solid on those things. Negative 8 plus 1 is negative 7. Negative 1 times negative 7 is positive 7. Add those together, that gives us 8. Negative 1 times 8 is negative 8. And when you add those together, we get negative 18. What is negative 18? It's the remainder. What else is it? Negative 18, just a reminder, negative 18 is also the value that you get out of that function if you substitute negative 1 for x. Negative 1 to the 4th minus 8 times negative 1 squared plus negative 1 minus 10 is negative 18. Okay, the synthetic division process gives you that, and we'll look at that tomorrow with the remainder theorem, but I just kind of want to keep that in the forefront of your mind. All right, so our answer starts with what power? X to the 3rd power, because we're dividing a 4th degree polynomial by a 1st degree polynomial, and our answer is going to start with a x cubed. So 1x cubed minus x squared minus 7x plus 8 plus negative 18 over x plus 1. Now, if we revisited what we did on Friday and did the long division process, there's significantly more work involved with long division. Okay? All right. Try this one on your own. Okay, everybody take a break here and check your setup. Make sure you set it up correctly. What are you likely to forget here if you're not careful? The 0 for the x to the 4th power. Yeah. Everybody get that? 0? Everybody stop and check. Look up, make sure you're correct here. Okay. Multiply and add. Do we get some big numbers here? 3 times 38 is 114. 108, 3 times 108 is 324. 324 plus 25 is 349. So if you got 349 and you did the process correctly, right? It's like I was telling you earlier on the long division problems. If we, on the test, that's the first thing I look at. If your remainder is correct, then your problem is correct. All right, because our dividend has a 5th power and our divisor is a 1st degree, our solution is going to start with x to the what? fourth. So I'll have 1x to the fourth plus 3x cubed plus 12x squared plus 38x plus 108 plus 349 over x minus 3. All right, and what else does this 349 tell us? Not a y-intercept, it's a point, right? It's the y-coordinate. If x is 3 on this function, 3 to the fifth, it's 3x, 3 times 3 cubed. If I plug 3's in everywhere there, I get 349 as an output value for that function. Okay, all right. Now, what's different about this problem? Now, the directions here say to perform synthetic division. The squared, right? How does that complicate things? How does this square complicate things? Synthetic division starts with what process? Finding the root of the divisor. What's the problem there? The divisor has 2 roots, doesn't it? And they are irrational, right? So which root would you use in the synthetic division process? The answer is neither, okay? If you don't have a linear term out here, this is a quadratic term. If your divisor is not linear, you cannot use the synthetic division process, okay? I'm going to take it a step further and tell you that if your root here is, and you'll see this in some of your homework problems, I think, if this coefficient of your linear expression even is, and if we were dividing by something like 2x minus 3, it's just easier to do long division. All right, it just is for the actual division process. Now, if we just wanted to evaluate, that's different. But this problem cannot be or should not be done using synthetic division. All right, this x squared here term tells you that this has to be divided by long division. All right. Okay, your homework is page 350, 17 through 29 odd. Don't forget the zeros. Yes.